Okay, so we've got Cauchy. Sigma a squared, sigma b squared greater than or equal to sigma a b all squared. And what I'm going to do is what you should always do when confronted with a new mathematical truth, which is to try it out with simple values or simple substitutions. And what I'm going to do, I'm going to say that the sequence of A is just going to be A1, A2 up to AN, and B is going to be the simplest thing I can think of, which is not 0, which doesn't have a 0 in it, just a column of ones, just ones. What do we get? Sigma AI squared times sigma of bi squared greater than or equal to sigma AI bi squared. So let's just substitute in. We've got sigma AI squared times sigma bi squared. Well, what's that? That's just n, because all the b's are 1, so we've got 1 squared plus 1 squared plus 1 squared plus 1 squared, all of these ones all adding together. And I'm asserting that's greater than or equal to sigma AI times 1 squared. Well, this is quite nice. This is quite a nice little thing. It's quite useful. I'm going to muck around with this a little tiny bit. I'm just going to mess around with this as an inequality. I'm going to take the square root of both sides. I'm going to say root n times sigma ai squared, square root of that, is greater than or equal to sigma ai. Just assuming everything's positive. And now I'm going to divide by n. So I'm going to say it's the square root of sigma ai squared over root n greater than or equal to sigma ai over n. Actually, I'm going to rewrite that again. It's 1 over n times sigma ai square root of sigma ai squared over n. And it should be obvious to you that this thing here is the arithmetic mean of the a's, because I'm adding them all up and dividing by how many I've got. This thing, it's the square root of 1 over n times sigma ai squared. That is the quadratic mean of the ai's. Sometimes you'll see it called the root mean square, or at least that's how it appears in electrical engineering. So the quadratic mean of the a's, let me write that out again. The quadratic mean of a is bigger than or equal to the arithmetic mean of a. So that's the quadratic arithmetic, no, you say quadratic mean, arithmetic mean inequality. And this is one of a number of mean inequalities, inequalities of averages of different types that you see in statistics. Well, you see it in mathematics and, well, specifically statistics, because that's my area. This is enormously useful, and we'll see in the examples that we can use this inequality over and over again. It saves a huge amount of thought. It's quite a nice little inequality. And I'm going to stop there.